Hello. For this video, I am going to cover how we look at solving inequalities that involve an absolute value. And this is similar to the question number 2 out of the module 1 assignments in Mobius. Okay. So a couple of things to talk about previous to just working through this example is some of the general rules when adding, subtracting, multiplying, and dividing with inequalities, right? So when we have an equal sign, there's really nothing to consider if we're minusing or adding from one side to the left. However, when we have an inequality, adding and subtracting is same as if you were just with an equality, strictly equal sign, right? With our multiplication and division, what you have to do if you multiply or divide by a negative number, you must flip the sign of your inequality, okay? So here we have our inequality, right? This one happens to be greater than or equal to. And so if you multiply or divide by a negative, you must flip the inequality. Okay, so that means my greater than or equal to becomes less than or equal to. So I have to flip it, right? Or vice versa. And that is if I divided by or multiplied by a negative number from one side to the other. Okay, we don't run into that in this problem, but I wanted to highlight that to you because there will be problems in this problem set that rule impacts. Okay, so when we want to solve this inequality, because of this absolute value sign here, the first thing we want to do is isolate our absolute value sign. So in order to isolate that, this is what we need to isolate. Okay, so in order to isolate that, we can minus 5 from both sides. Okay, when we do that, we get x, the absolute value of x minus 2 is greater than or equal to 6. Notice I kept that inequality sign the same because I was subtracting. And again, the only time we flip the sign is if it's multiplication or division. Okay, so now that we have our inequality here, and our absolute value sign is the only thing on that right hand side of the equation, what we could do is the rules for absolute values is we need to split this out. So we have to, it's either the absolute value and we can drop the absolute signs, right? So either x minus 2 is greater than or equal to 6, or x minus 2 is less than or equal to negative 6. So notice I have flipped the sign because I've added this negative 6. So you could think of this as I'm just multiplying this whole thing by negative 1, roughly. I mean, that's kind of, it's not exactly what we're doing, but that's what you can think of it in terms. And because we're adding this negative here for the other side, we're going to have to flip that sign. Okay. So now what I need to do is just solve each of these inequalities. So if I'm going to add 2 to both sides, then I get that x is greater than or equal to 8. Or the other one where I'm adding 2 to both sides, I get that x is less than or equal to negative 4. Okay. So part of this problem said that we had to write this in interval notation. Okay, so for me, I find it easiest to write something in interval notation if I draw out a little number line, okay? So I'm going to draw myself a little number line, and I'm going to put my two values on it, okay? So one of my values is -4, and my other value is +8. So I put those on there. Because this problem has an equals with it, I'm going to put a solid dot on each of these. That means that number is included in the solution set. Okay. If I was strictly less than or strictly greater than, I would put a hollow dot. And when I'm looking at interval notation, I'm going to put a parentheses instead of a bracket. Okay. Now, the other thing I want to point out to you is that this arrow here tells me the direction of my arrow here. So this is telling me -4 is a part of the solution and everything this way. So notice that this arrow matches with this arrow, okay? Similarly, I have let me get a different color. Let's do this one. Similarly, I have my +8, right? And this arrow shows me which direction it's going in this direction. So you see those arrows match up, okay? Now that I have this, I can go, okay, so this arrow here is telling me this goes out to -infinity, okay? -infinity and +infinity always, always, always get a parentheses because we can't pinpoint an exact value, okay? So it always gets a parentheses. So we put parentheses infinity, comma, -4, and we get a bracket. We get a bracket because that solid dot tells me that the -4 is included in the solution, okay? Or that's that upside down U, meaning the union of these two, okay? And then my solution can also go from 8. 8 is part of the solution, so I get another bracket. And anything all the way out to +infinity is also going to be part of that solution. And again, that ends with the bracket, with the parentheses, because we can't actually pinpoint the exact value of our whatever that value is out at infinity. So this is the solution right here that Mobius is looking for when they ask you to solve that inequality.